Hello everyone and welcome to our event. First, I would like to tell you that I'm honored to open this event. My name is Florino Lariu and I'm technical manager working for Centric IT Solutions since 2012. Together with my colleague Mihaela, today we will try to facilitate this event as moderators. Today is an important day for us, given the fact that we have invited a very special guest. Before going further, I want to give you more context about this event. This is the third year in a row when Centric is organizing this kind of events. Unfortunately, due to these pandemic times, the event now is online. But anyway, we are happy given the fact that we can continuing this tradition. The event consists from two parts. First one is the talk related to the microservices and serverless, and then we will have a session of questions and answers. Before introducing my colleague Mihaela, I would like to tell you a few words about Centric. Centric is a Dutch company with headquarters in 7 European countries. We have more than 4,000 professionals that are creating the company products and also delivering outsourced products. Some of the areas where Centric products can be found are public sector, supply chain, HR and payroll, infrastructure, XR. In Romania, Centric has one of the research and development offices where more than 300 experts are building the tools for our customers using a wide technology stack. Please allow me to mention some of them. We are using here .NET Framework, .NET Core Framework, Java, HTML and CSS, Angular, React, and so on. Please allow me to invite Mihaela. So, Mihaela, it's your turn. The stage is yours.
Hello. Thank you very much, Florin. I'm Mihaela Ghidersa, and I'm a software developer at Centric. And today I want to share a little something with you. In a discussion with a friend the other day, he was joking and saying something like, in a world full of monoliths, be a microservices architecture. Well, I would say in a world full of BFFs, microservices, monoliths, and other structures, choose the one that just fits your needs and the way your project needs to be built. Today, whatsoever, we are going to discuss how good microservices and serverless go together. We are going to look at the mapping between the microservices and functions, the limitations of current offerings in terms of providing logical separation, and get some tips on how to best start making use of this new technology. To guide us through this subject, together with us virtually, is our speaker, special guest, as Florin said, Sam Newman. Sam is a technologist, independent consultant, speaker, and author of Building Microservices and Monolith to Microservices books. So I'm sure that if there are some questions that remain with you from the book, he will be just more than happy to answer. Without any further introduction, dear virtual fellow programmers, please let's welcome Sam. Sam, the mic is yours.
Thank you so much indeed. I just want to say a big thank you to Centric for inviting me in the first place and making this whole thing possible. I was really hoping to be able to be with you in person. It would have been, I think, my second or third time to Romania, but it wasn't to be. Maybe in the future we can make it happen, but for now we'll have to make do virtually. I am going to be talking to you about microservices and serverless. I'm going to share my screen, which is always a daunting exercise because there's a very good chance you end up sharing the wrong thing. So do wish me luck. Okay, here we go. And that's the right screen. Yep, and there we are. So microservices and serverless. A very brief bit of background. As was mentioned, I did write a book called Building Microservices. I wrote this book a while ago. I wrote this book before we were talking about serverless much. So to an extent, this presentation is sort of what I've been doing over the last few years to sort of update my own thinking about how microservices map to the serverless concepts. At the end of last year, I had a new book that came out called Monolith to Microservices, which is kind of talking about the sort of deep dive into taking an existing system and breaking that apart and moving towards a microservice architecture. There's lots more information about that if you want to find out how to read that over on my website. But enough with the, and now I also sort of do work with sort of doing training and advisory work. I do a lot of consultancy online as well. If you're interested in the work I do, go look at my website. I won't need to cover it off again here. But we're here really to talk about microservices and serverless, and they're kind of concepts which sort of seem related, but we should probably start off with the basics of talking about what microservices are. There are different definitions out there. This definition is mine because I wrote the book, so I get to define them. Here are microservices. I talk about them at different levels, but at one level, I describe microservices as being independently deployable services that work together, modeled around the business domain. This idea of working together, it makes sense. Not all the functionality is in one place. One microservice might need to make use of functionality that lives somewhere else. That's fine. But we also want these things to be independently deployable. When I talk about independent deployability of a microservice, I mean this idea that I can make a change to a microservice, deploy a new version of that into my production environment, release that functionality to my customers, to the users of my software, without actually having to change any other parts of my system. Making independent deployability work is difficult, it's hard, but it is worth it. It makes it easier for you to ship software, makes it easier for you to have teams working in isolation, makes things like zero downtime deployment much easier to implement as well. And most of the stuff I talk about, most of what I cover in my books and my presentations is dealing with the realities of how we make that work. If you remember nothing else out of the talk today, remember independent deployability. That's what you want. I want to be able to make a change to a microservice. I want to be able to deploy that change without having to touch or deploy any other part of my system. If we think about how we typically think of microservices being implemented, normally, and certainly if we're not looking at, say, function as a service-based deployment, although even then that can vary, we think about a deployment of a microservice being one or more instances. So I've got my shipping microservice and I might have multiple instances of that shipping microservice deployed. Each one of those instances is normally a full process. So all of my code and functionality for shipping microservice is deployed as a process. I might have multiple copies of that in order to to give myself some degree of robustness or to handle additional scale. Communication between those microservices is done via some form of network communication. And there's different variations on those protocols. But you can think of a microservice as a collection of business functionality which is exposed over one or more network interfaces. This is how we communicate with each other. So these could be, HTTP calls, gRPC calls. You could be using messaging protocols, whatever else. When we think about data, and we'll come back to this a bit later on, we hide data inside our service boundary. So if the shipping microservice here needs to store or mutate state as part of the job it's doing, the detail of how that is done is hidden away inside that shipping microservice. Outside parties are unable to reach in and directly access that data because that undermines our drive towards independent deployability. Ultimately, independent deployability plays out as a benefit to us in so many ways. But one of the words I keep coming back to and hearing again and again as a reason why organizations are adopting microservices, it's because of this. It's this word, the A word, autonomy, right? That people are saying we want our organizations to have more autonomy. And what they really mean by that is they want teams working more in isolation, being able to get things done without having to communicate with other people or reducing the degree with which they have to communicate across teams. This is about distribution of responsibility into those teams, allowing them to make decisions and go more quickly, moving away from centralized or too much centralized command and control. And ultimately, microservices are absolutely an architecture which allow you to optimize for autonomy. So these things go hand in hand. We've got the unit of the microservice, which is an independently deployable unit. If we want teams to be autonomous and they own these independently deployable units, well, those ideas go really, really well together. And there are other systems and platforms and tools out there which are also all about helping us embrace this concept of autonomy and allowing us to sort of do more ourselves rather than having to raise tickets and get other people to do work on our behalf. If we think about public cloud providers, you know, a lot of the drive behind them is actually about improving autonomy. If you think about all these virtualized cloud products, you know, and you think about the base level of storage, compute, whatever else, all of the services offered by Azure, Google Cloud, and AWS are all accessible via self-service interfaces. Yes, sure, you can use a web UI if you really want to. You probably shouldn't though, especially the AWS Web Console, which is a bewildering thing. But you can use APIs. You can automate all of your infrastructure. Here we're sort of allowing teams to have improved autonomy through self-service. I don't need to get somebody else to look after my infrastructure. I can now do it myself. And platforms like AWS, Azure, and Google Cloud are giving that to me in a way that we didn't really have before. These sort of cloud-based solutions are really kind of virtualized abstractions on top of core infrastructural ideas. So they're giving us an abstraction over a disk, an abstraction over a unit of compute, an abstraction over a piece of storage or messaging or something like that. And when the public cloud providers first started coming into our consciousness, you'd say in the mainstream, the term that got used the most was this, IaaS, infrastructure as a service. And this was certainly the AWS big selling point. This is not where Amazon started with Amazon Web Services, but it's where they made their money and where they still continue to make most of their money. And this is by taking the fairly low level compute primitives that we think about, also low level sort of infrastructural primitives of compute, network and storage, and providing an abstraction layer on top that allows for those things to be virtualized and automated. And the driver is here, rather than managing your own physical infrastructure, you're just calling an API and it's being managed for you. So we're sort of increasingly moving towards abstractions that distance us from the underlying hardware and instead give us more power. We can get things more done because we're not worried about the hardware, we're just talking to an API. Containers, to an extent, have continued this trend, and we see containers being used a lot in the context of microservice architectures because they give us a simplified abstraction over a running instance of a microservice. I can package up an instance of my microservice as a container, and using an appropriate container platform can just deploy one container just like any other. The idea here is that we think of the metaphor of the shipping container, right? The shipping container, they're all the same from the outside. They've got the same dimensions. They've got the same hook points. The truck carrying a container doesn't care if there's a car in that container or grain or stereos, it's just the same. And this allows for a standardized set of trucks and cranes and ships that can carry containers all the way around the world. And the containers in the context of software development work in the same way. We don't actually have to care what's happening inside the containers. We're just dealing with them at a unit of abstraction. So for me, the difference between deploying a container running a Java microservice or a Ruby microservice or C# microservice, I don't care. I just drop it and deploy it. Now, containers have actually been around for quite a long time. And to be honest with the early types of containers weren't anything like what we've got today. They weren't really like shipping containers with a nice generic tool chain. That really all shifted with Docker. So Docker took previous concepts around containerization happening in sort of Unix and Linux kernels and really came up with a great tool chain to allow us to package these things in a different way. They gave us a unified form of deployment in terms of the images and sort of nice command line tools to work with those things. And so we're getting more and more options. We've now got infrastructure as a service. We've got things like, you know, managed virtual machines we can deploy our microservices onto. And then containers came along. And the reason containers were interesting to us is because they're actually much more lightweight than virtual machines. And so we could actually run more microservice instances in an isolated fashion on the same equivalent hardware. So for a long time, when using container workloads and still running, say, on a public cloud provider, what you would commonly do is you would spin up, say, a managed virtual machine. So the managed virtual machine service on AWS is called EC2. the Elastic Compute Service. You would then run some kind of container engine on top of that, which allows you to manage the containers running on top of that virtual machine. So then I could have a container for each one of my microservice instances. And this gives you fairly cost-effective isolation here and uniform deployment. And what I mean by isolation is that I can actually assign some of the underlying resources of this virtual machine to individual container instances. So if one container instance starts chewing up all my CPU, it's limited in how much it can affect the rest of the containers running on this VM. If one of those containers dies, the other containers really just don't care. Now, in the early days of Docker, this was fine for managing a single machine. But we then have issues, which is like, actually, I don't want all my system running on a single virtual machine. I actually now need multiple virtual machines or multiple physical machines to manage my workloads. Perhaps because I need more capacity, or just because I don't want my entire system to shut down when one EC2 instance gets terminated. But you'd have to sort of manually work out where these containers go and how to distribute them everywhere. And this is where platforms like container orchestration platforms like Kubernetes come in. And at a base level, all Kubernetes is a scheduling system for containers. It manages a pool of underlying resources. You go to Kubernetes and say, here's some containers. Can you spread them around for me? And I'm simplifying greatly what Kubernetes is, but at its heart, that's what it is. It is a pretty good way for managing and deploying containers. I don't think it's the best container orchestration platform out there. In terms of being, the best in terms of just container orchestration, I think you could argue that Nomad is better, but it's the best ecosystem. So around Kubernetes now, of course, we have this massive tool chain that makes these Kubernetes-based platforms so much more powerful. So we've kind of gone from physical hardware to virtual hardware with an API on it for the public cloud providers. Now we're running containers on top of that. And you can kind of just see this as continually better forms of virtualization. Okay, virtualization being taking a physical resource and creating virtual machines out of it. And then a virtual machine, we're creating more kind of virtual machines out of it with containers running on it. Remember, inside a container, you're running an operating system. So I've got an operating system on an operating system on an operating system, and this can get quite confusing, as we'll talk about shortly. And then comes along serverless. And the term serverless has actually not been with us for that long. It's been around since about 2012. And the term was first coined by someone called Ken Fromm, and Ken was talking about the types of cloud products that he was seeing coming out from the main the big three vendors. And he was realizing that what was working well for people was services that kind of abstract us from the need to even worry about underlying machines. We're distancing ourselves from the idea that servers even exist. When I spin up a virtual machine, I'm still saying I want a virtual machine with this much CPU, with this much memory. When I put a container on that, I'm still mapping a container to that machine or saying how much of a CPU does it want, or how many copies do I want of that container instance. Serverless takes us even further away from this. We don't actually have to worry about even those details. We just say run this or store this, and we're away. Now, for a lot of people, the term serverless is the same as function as a service and FaaS. And it's not really strictly speaking true. It's true to say that function as a service, as typified by something like Azure Cloud Functions or AWS Lambda, they are under the umbrella of serverless, but serverless covers way more than just functions. We've obviously got function as a service, but serverless offerings also include the database as a service offerings. We've got storage, things like Amazon S3. Amazon S3 was launched in 2006. AWS gave you a serverless storage option before infrastructure as a service was a thing. So serverless actually predates infrastructure as a service by at least a couple of years. Actually the earliest ever AWS product launched in 2006, just before S3, was Amazon SQS, a simple queue service, a serverless queue. Both Amazon S3 and SQS have this property where you're not saying I want to allocate some disk space or I want a certain number of machines. I'm just storing data or sending messages. And the underlying platform is working out what it needs to do to deliver on my requirements. And there's more. Now, a lot of focus is obviously in that space of function as a service, but it's many and varied, and all the main cloud providers have a set of options in this space. I would say that Google are certainly maybe have a less rich set of offerings in the serverless space, certainly around, although their database stuff is very good, they have more limited options in terms of things like messaging, and their function stack isn't nearly as good. But, you know, even just with AWS, we can think of Lambda, DynamoDB being an example of a serverless database. They've also got Aurora in that space and SimpleDB, although I wouldn't use that. And so we think back coming back to this idea that this is just a new set of abstractions. We start off with our physical infrastructure, and we thought, well, dealing directly with physical infrastructure is painful, so we virtualize that. So we can break it apart, a physical machine into lots of little virtual machine. And we virtualize these primitives, compute, network, storage. This is the infrastructure as a service level on the public cloud, or maybe just the virtualization level within your own data centers. We then thought, no, we can do better than that. What's the next level of abstraction we can work with? Well, we've now got sort of container orchestration as a service. We've got things like managed Kubernetes services like AKS on Azure or EKS on AWS, and AWS obviously also have things like ECS, which is a different type of container orchestration system that's not related to Kubernetes, but also services like more managed databases, like having fully managed relational databases on Azure or on AWS. I'm not provisioning a machine and managing a database myself. They're just saying, here's a database. I might still need to say how big it is I want a machine to run it on, but it's still a higher level of abstraction. I'm hiding details away from myself. I'm pushing more of the details to the underlying platform provider. And then we've kind of got our serverless offering sitting on top here. Functions as a service, backend as a service, messaging and storage. I'm being further and further removed from that. And there still are some platforms as a service out there. And platforms as a service are even higher level abstracted, but they kind of hide even more detail from you. So as we go up this technology stack, right, up this level of abstractions, we're moving into a world where we hopefully have got less and less infrastructural operational overhead. And with microservices, reducing your operational overhead is good, because when you move to microservices, you put a lot of complexity into the operational space. So if we can offload that, we're in a happier place. As we come down this stack and we get into lower level detail, you're going to get much more low level access and a finer degree of control over how things are done. So if you want to offload a bunch of work to somebody else, you're going to have to buy into their abstractions and accept that means that some things are not allowed for you to be done. You can't access some things underneath the hood because they're hidden from you. And that's the trade-off. How much are you willing to give up in terms of control to get, an easier life? And the reality is, a large amount of the time, you don't need the level of control that you get from these lower levels. And that's the key thing, is I'm giving up on things I never use. So I'm okay buying into Lambda or Cloud Functions or something. So as I mentioned, these sort of abstraction stacks can get quite complicated, especially if you start running them yourself. Right? If I was going to run a full virtualized Docker stack onside my own physical infrastructure, I start off with a physical machine, right? I would then put an operating system on that machine. I'd then put a hypervisor on that operating system. And the hypervisor is the thing that manages virtual machines and maps physical to virtual resources. On top of the hypervisor, I would put a virtual machine operating system. On top of that, I'd then maybe run my container library of choice, in this example here, Docker. On top of Docker, I would run my container instance, which includes a container operating system and also my application code. Now, if I'm managing all those moving parts myself or inside my own organization, this starts to look quite a scary proposition. This is the promise of public cloud, though, is that we can offload some of this to somebody else who can probably do this job of managing these lower layers better than we can. I don't mean to offend any of you, but I strongly suspect that Google, Microsoft, and Amazon are better at building, running, and maintaining data centers than you are. I don't mean to say that you're bad at your job, just that they are operating at a level of scale and efficiency that is very hard for anyone else to match. And they're doing these things, they're doing some crazy stuff, like they're designing their own chips and their own BIOSes and all this sort of stuff to tune every last ounce out of these things. This is the promise of outsourcing when it's done well, of course, is that you're getting somebody else to do a job better than you could do it for yourself, freeing you up to do what makes you special and what makes your company special. So if I go to the cloud and I just use managed virtual machines and just say, I'm just going to use EC2 instances, for example, on AWS, straight away, I've lost a whole lot of layers I don't need to worry about anymore. The hypervisor, the underlying hardware, that's all now being managed for me. I'm still having to manage the operating system on the VM and things like that. But if I say, you know what, no, actually, I'm now going to deploy in containers, and I'm going to use a managed container platform. Now I'm only having to worry about my application and my operating system. And function as a service potentially gets us even further. I can now say, you know what, all you now need to worry about is your function or your application. So some function serverless, though, gets us into this world of abstractions. And the way I've kind of made it make sense in my head is like containerization is like a better form of virtualization for us. But I think serverless is a better form of abstraction. Containers in a way aren't that different to virtual machines. We've got a slightly nicer tool chain, they're more lightweight, but the abstraction is really still fundamentally the same, more or less. I'm still dealing with storage, compute, networking, numbers of instances. Serverless takes me away from that world. And that's actually what I think serverless is. Let's be real. I'd imagine a lot of you have spent time working with Kubernetes. It is not developer friendly. It just isn't. If you think it's developer friendly, you're wrong. It's because you spent too much time working out how to work with the thing. Serverless, I think, when done well, is much nicer level of abstractions for the average developer. And by the average developer, I mean people that have got not enough time on their hands to read through reams of documentation about how to run Kubernetes and learn about the massive tool chains in that space. Don't get me wrong, Kubernetes is fantastic, but it is detail that most developers should never need to be near at all. I've talked a bit about fast, and I know I've said that, you know, serverless isn't just fast, it is an important piece of fast, especially when we start talking about how serverless and microservices can work well together. So just to give you a bit of an overview about how it works. So the way function as a service works is you have an underlying fast platform, and there are on-prem options around this. I'll talk about those later, but you know, you're probably running this on, say, a public cloud platform. And what a fast platform is going to do for you is automatically invoke a function for you when some kind of predefined event happens. So you basically say, look, when this thing happens, launch an instance of my function. Now, of course, function here is kind of a loose definition of the word. You know, we can talk about pure functions and all this. For some people, function equates to size, and that doesn't actually really matter too much. This could be 500,000 lines of code if you wanted to. Doesn't actually matter. So it's a piece of code that you wrote that the platform is going to launch for you automatically on demand. You don't need to tell it when to spin up. You just need to tell it what causes it to be launched, and the platform handles all the detail for you. These jobs are time limited. So when a function launches, there's a limit on that. Those limits used to be quite tight, but I think on AWS Lambda, each function invocation can run for up to 30 minutes, I think. It might even be in an hour now. You can do a lot in an hour, right? An awful lot in an hour. How many of you have a system that takes a single request that sits there running for an hour? Normally you don't, right? You normally deal with that in a few seconds and then you're done. Still, there might be some workloads that won't work for you because of that time limit. So these things can be triggered by API calls. You can have these triggered by a message arriving on a topic or something. You can have them triggered by file. You could even have them triggered based on some time. This is a good way to actually implement sort of cron type functionality on these things. What the fast platform also handles for you is scale. So if another request comes in, it launches another function, and it keeps launching these functions as more, triggers of calls until you've reached your limit. So you don't have to worry about provisioning more machines. It will just keep spinning them up. Amazon will quite happily just charge you more money for that. You can place constraints on how many concurrent invocations you have if you want to protect your bank balance, but the platform does that for you. Other nice thing is when the function is no longer being used, it's turned off. When that request is handled, that API call is handled, the function sort of vanishes. You don't pay for it. You only pay for what you use. If your function never gets hit, you don't get charged. That's it. That's going to be a nice idea, right? Like, I'm not worried about it, about how much money it's costing me. Now, that can be useful early on when you've got a system where you don't really know what your load's going to be. There are some interesting quirks here, though, that initially, if you've got kind of fairly sparse load, this can be significantly cheaper than running your own VMs. for both Microsoft and Azure, though, when you get to a certain usage pattern, it can sometimes be more cost effective to go back to virtualized machines, but that's like an expert level conversation we can have later. Now, functions, they're spinning them up on demand, they're shutting them down later, they actually provision fairly quickly, even for JVM and CLR workloads. So that's pretty good. And the reason they kind of provision to get spun up so quickly is because behind the scenes, they're basically using containers. So containers are there, but you're not having to worry about them. You're saying, here is my code. The platform is dealing with all the detail for you. It's taking you further away. Sure, containers are amazing and they're brilliant and they're great, and you don't need to worry about them because it's just hidden and handled for you. There are some constraints. I've already talked about the limited execution time. You also do have limited runtime choices. So you have to have the underlying FAST platform has to support your programming language and version of choice. This is much less of an issue than it used to be. Microsoft is leading the way in terms of having the broadest sort of support for different languages and runtimes. AWS is not far behind. This is definitely, though, where Google are way behind. It's taken them a very, very long time to roll out new language versions for their own cloud functions, which really makes it less of a viable option unless you're using languages they already support. You obviously have reduced control. You typically get to say, what is it that triggers my function? What are the things? You might be able to say how many function invocations, and you can say how much memory your function has. And that you get charged more with a function that has more memory available to it. And that's kind of it. Another big constraint, which can cause issues for some workflows, is the concept that the functions are effectively stateless. So when, as I mentioned, when your function is no longer being used, it kind of shuts down. It's not strictly speaking true, because there's some sort of optimizations that are done behind the scenes, but you have no ability to carry state between function invocations within a function runtime. So if you're used to, say, using shared state within a running process, this is going to be difficult for you. Now, there are kind of ways around this, and we might come back to those later on, but you should kind of think of each function as being entirely stateless. So if you need to persist state between function invocations, stick it in a database and you'll be fine. We've also, of course, got database as a service offerings as well, of which there are many, and we'll come back to those later. So let's change track a little bit. Let's think about microservices. So I've got my microservice instance, my shipping microservice. And as I said earlier, a common thing for me to do is to take my microservice and actually deploy it as multiple instances. So I might want multiple copies of my microservice to handle more load, or to be more robust in case one of them fails. I can still provide a quality of service to the people using this service. So multiple instances. In this case, we're all talking to the same database because they all start part of the same logical microservice. This is all good. Now, I might also then have some duplication or I might do something with my data tier here. So I might use some kind of replication scheme where I might have a read replica. So I might have a primary database for writes and reads and read replicas to scale it, or maybe some sort of hot or warm failover in case my database fails. I might then think, okay, so I've got some redundancy in my database. I've got some duplication in my instances. Great. If I want to make my system more robust, I may then distribute these across failure planes. For example, I might run one of my shipping microservices on one availability zone, one on another, one on a third. So on different machines in different availability zones, if one of those availability zones dies, my system still keeps running. Oh, and by the way, you have to distribute your microservice across availability zones because none of the cloud providers give you an SLA for an availability zone. You do not get one. You only get availability for compute across the entire service. So you have to distribute your solution across multiple availability zones on the public cloud. So this is all work you've got to do. You've got to reason about it. How do I distribute these things around? Now, Kubernetes can do some of this for you, right? When I go to Kubernetes, I say, here is my container. I want there to be 3 instances. Please distribute it across machines for me to give me some failure plane distribution, and it will do some of that work for you. But this is what I'm doing, and this doesn't actually change much with the different ways we deploy microservices, right? It doesn't change for virtual machines or running directly on physical hardware or containers. The models are all pretty much the same at this point. We're also sitting there waiting for something to happen, whether or not we're needed. So that's kind of the pre-function as a service world. This is totally different with function as a service. I don't say how many copies of this am I going to have. I just say there's a max number of these things could be invoked, but right now that number could be 0. I don't tell it where those functions need to be launched. I don't have to worry about failure planes. That is all handled for me by the underlying platform. That's a whole load of work and effort and energy just gone from my head. And that's a wonderful thing. So I start thinking, okay, great, functions sound great, Sam. I've got my shipping microservice. So just exactly how many hundreds of functions does that now equate to? And this is where people start getting themselves into a bit of a mess. You don't want hundreds of functions. You don't need hundreds of functions. Do you know what you could deploy as a function? A single microservice instance. There's 0 reason why you can't do this. You just take your current microservice instance and say, I'm just going to make it a function. You just have essential input point, a bit of a dispatcher function inside your running function itself, and you're away. And this is a very simple conceptual mapping. It just gets spun up like before. You're not having to break things apart. You're not having to break apart your code. We've got a single deployable unit. And probably in a fell swoop, we've drastically reduced the amount of infrastructure work you have to do. And we've kept things nice and simple and straightforward. And you might say, Sam, a whole microservice instance can't be a function. And I would say, why? The definition of a function here is pretty vague. It's certainly not a mathematical definition of the word function. This is absolutely fine. No reason why I can't do this. If you can have a function that can call other functions, if I package up that parent function, all the other functions are inside it, ergo, this is okay. Now, of course, this might be still quite big and people start thinking, well, functions are so easy to deploy. Why don't I break this down into smaller pieces? So then we have to start thinking about, well, what do we do if we want to move away from one big giant function as a microservice instance? The nice thing about this, of course, is at this point, it spins up and it scales out on demand. I don't even have to worry about it. Just, all this stuff's handled. All I've got to do is get the memory right, and I'm away. So if you want to start breaking this thing down into smaller pieces, this is when you start moving from the microservices being a unit of deployment to being more of a logical construct. So this example here, my shipping microservice is now no longer one big function. I've broken it down into 4 separate functions, maybe handling different parts of that shipping microservices responsibility. My shipping is more like my shipping microservice is now more of a logical grouping. When you do that, it's really important to sort of not expose those functions directly to the outside world. So up here, I've got all these other consuming services. These are our consumers, right? These are the people. They're probably not human beings, but they're other microservices that are going to use our shipping microservice. From their point of view, they should just treat us like the shipping microservice. That's the logical thing they work with. They shouldn't have to care that we've broken things apart into lots of functions. We should see the decomposition into functions as an implementation detail. If I decide to merge those functions back together into one thing again, it shouldn't affect the outside world. This is an example of what we call information hiding, right? I'm hiding information inside that boundary. And that's really, really important. So then all I need to do is be able to route these calls so that they can transparently get sent to the function or to the to the individual function or a separate function. There's a load of different ways of doing that. So if you hide that detail as well from the outside world, you've broken it now apart into 10, 15, 20 different functions, you get to change your mind, merge those back together again, and the people from the outside that are calling your function calling your microservice do not care. So they shouldn't care that your microservices deploy as functions. They shouldn't care if it's deployed on a Raspberry Pi or as a Kubernetes container or on a quantum supercomputer. All they care about is they call your endpoint and your service works within the kind of accepted criteria. That's it. They shouldn't care at all about what happens inside that box. So this is also a great way of getting started with using functions as a service in an existing microservice ecosystem. You could pick one microservice and just try it out. Doesn't work, you can roll it back. No one's going to notice. We still here want to limit access to the data, right? So for us, the data is still kind of part of our logical microservice boundary. And that's a really, really important idea in microservices, which I'm not going to go into in too much detail because there are books out there. Now, when you want to break things down smaller, the question then is, well, how do we find what the smaller thing is? And I've changed my mind about this a little bit, but my default place to start with microservices is thinking about microservices in terms of sort of domain-driven design and in kind of terms of structured programming, right? So I'm looking for self-contained units that can be broken apart safely. And when I'm breaking things down to smaller and smaller and smaller pieces, the smallest piece I'll go to is what in domain-driven design speak is called aggregates. So an aggregate is something that you're going to store as a set. It's like one definite, an aggregate you can think of as a collection of objects that you store together, right? All of the code that manages that aggregate, effectively you can treat management of an aggregate like a state machine. So like the root aggregate here, all the functionality that relates to how a root can change, the state machine around those operations, I want to make sure that's maintained together to make sure that it has consistent behavior. The world starts becoming a fuzzy place when I start having the single aggregate managed by lots of different pieces. And it's one of the golden rules of domain-driven design is you don't split your aggregates. And so for me, this is about as small as I go. So in this context here, I've broken these things down maybe around aggregate boundaries. So I've got a delivery function which handles those aggregates inside that overall shipping microservice. And that sort of keeps things simple, and it basically allows you, if you want to implement aggregate management as a state machine. Managing distributed state machines is kind of tricky. So yeah, just in a nutshell, if you haven't done domain-driven design before, the concept aggregates are useful whether or not you care about the rest of the stuff in domain-driven design. So the definition from Eric Evans's book is that an aggregate is a cluster of associated objects that are treated as a unit from the point of view of data changes. So again here, if we break it apart, we now get into a world where we're sort of trying to apply data changes in a unit, but they're now no longer a unit. And as we all know, distributed transactions don't help us here. So part of keeping these things as a single unit is also so that any data operations associated with an instance of an aggregate can be handled within a normal transaction. So that's what we know. We don't go any further fine-grained than that. So when we break things down, so my shipping microservice might have 10, 15, 20 different aggregates. I might start to break them down around those boundaries if I really, really want to go finer grained. And so I end up with something like this. Now, as you see here, they're all still logically part of the same microservice. So I'm okay with them all accessing the same database. Over time, I might even say, well, actually, consignment now really, I could see it actually, you're only accessing part of your own data here in the database. So maybe I could, over time, split this apart into maybe being a new consignment microservice. And that might be something you do over a period of time, but that doesn't have to be done straight away. Right. So the next stage people go to is, well, why don't I take an aggregate and then break that down further, right? Why don't I have, the state transitions of an aggregate, each model is a separate function? I used to suggest this model, and I've definitely gone back on what I thought. I don't think this is a good idea. I think it's going way too fine-grained with our processing, and I think leads to that problem now. I've got 15 different functions that are all supposed to implement effectively a single state machine. How do I make sure that all these functions are behaving in a consistent way? It just gets too difficult to do that. So I wouldn't go any further than sort of a single aggregate in terms of the fidelity of these functions. Okay, so that's great. So we've replaced our microservice instances with functions, one or more functions maybe, but we're still talking to the database. But what else could I do? Well, we've got all this rubbish that we have to deal with at the database tier. So why don't we also consider using some kind of serverless database? Well, this seems like an easy, quick win, right? Because serverless databases we just throw data in, it charges based on what we use, it handles sort of failing, zones failing for us. It just automatically allocates capacity for us, theoretically. So this should be another quick win. Databases are a pain to manage. Well, yeah. So, yeah, but a lot of serverless databases are quite different to other databases you've worked with. Now, there are exceptions to this, but if you're used to, say, working with, say, Postgres or MySQL or SQL Server, and then suddenly you start trying to work with Cosmos or DynamoDB, they're kind of like funky databases, right? They don't really exist anywhere else other than on, AWS and Azure, and they sort of look like a document database. They're kind of Mongo-ish, but not really Mongo-y. They've got some very odd concepts around like allocation units and stuff like that. And it's not just from a management point of view, they're a little bit different. They're different in a way that will often require you to have to change your code to work differently with that database. And that's a new step for you to go to. Now, a good example exception to this would be something like Amazon Aurora. So this is a serverless backend, but it gives you what just looks like a normal MySQL or Postgres database. So if your application is already built to use MySQL or Postgres, you can theoretically just swap in Aurora instead of a dedicated database, and it kind of works like a serverless backend for you. So that can be a fantastic, almost drop-in option to offload more of your infrastructure work. Again, at certain price points, you might want to go dedicated, but for a lot of stuff, this is just absolutely fine. And there are lots of options in the database space, and this is by far not anywhere near enough of the options. And there are some things you shouldn't use. Don't use table storage or SimpleDB, right? Google Cloud seems to have more database options than anybody else, which makes very little sense given that their cloud offerings in general they are nowhere near as feature rich as Azure or AWS. But Google has some amazing database. I mean, Spanner is kind of really weird. It's an excellent database, not serverless in any way, shape or form, quite expensive, but it also does things that no other database can. So if you're looking into niche, large scale data storage and requirements, Google Cloud have got some excellent stuff for you over there. No, we're going to skip this stuff because we're a bit short on time, and you can learn about information hiding kind of somewhere else. And so I'll just skip over this. I can't skip. Right. So one thing I want to talk about is some of these serverless databases can lead us into confusing worlds. With relational databases, we use this concept of the schema. And, I've got a logically isolated database, a logically isolated schema. That database has tables in it. And I can say one microservice talks to one database, and that microservice talks to lots of different tables in it. And when you move into some of the serverless databases, like Cosmos and Dynamo are great examples. They don't really have the concept of an isolated schema. The only real unit of logical hiding you've got going on is kind of account and user permission level hiding. So you just have a table. So I've got an invoicing table here, and I've got a customer table here, and it's sort of very hard for me to kind of define these boundaries around it. And I find a lot of people, when they move into using Cosmos and Dynamo, just still getting into this issue of like having kind of functions reaching over to multiple tables that other people are also using. And you end up with this sort of world where you've got this horrible kind of Cartesian product almost of like loads of tables being used by loads of functions and loads of functions being used by loads of tables, and it becomes a giant mess. There's still a really good reason to have logical isolation, right? If this is one team's responsibility, we do invoicing. Okay, well, that invoicing table is ours. Team B, they look after the customer. Okay, their customer data is theirs. I shouldn't be reaching into their database directly because they might change that in some way, right? So I need to stop doing that, right? I don't want backdoor access. So I have to kind of stop just reaching into other people's data. And I see people missing this. They got it with microservices, they go to serverless, and they make these same mistakes all over again. And so, locally grouping these based on aggregate is a good model. And then enforcing that can actually be done with sort of things like identity and access management permissions. I've spoken to a few teams actually that just auto-generate IAM rules to restrict access actually at that level. So if your application code tried to reach out to access somebody else's database, you'd actually get stopped. And to be fair, that's what a lot of people do manually with relational databases anyway. So I could stop doing things like that and say, if I want to get access to your data, I have to go and use a function in somebody else's aggregate to get the information that I need. Now, I mentioned earlier that functions are mostly stateless, and in general they are. You can't carry state between one function invocation and another. There's a couple of exceptions to this. There's a few. One example of where you can kind of make things stateful is AWS step functions. They're not really stateful. What they really are is a way of passing state from one function to another and chaining together workflows. I do not like step functions very much. So much of the work you do ends up being in JSON, and that's not a fun place for anybody to be in. If I want to actually, I think something that's much more elegant and I think much more developer friendly is durable functions from Microsoft. And that basically takes sort of reactive extensions in different programming languages languages and extends those ideas into function invocations. So I can do something like an async await inside my code and await the invocation of another function, at which point the function itself suspends, the other function executes, and then my other function is reignited again with the state coming back. It's basically using continuations on the back end. Now that's a really interesting distinction here. And this is a continuing thing for me, which I do not think that AWS as a whole understand what making developer friendly products looks like. We always end up having to use their stuff behind other people's abstractions. I think Microsoft is trying with durable functions to do that. And I think it's really smart how they've done it in a way that can support multiple different languages. So if you are interested in sort of stateful functions, do take a look at that. It doesn't look like the kind of thing AWS will ever do. I don't think they would, it's not the way they work. I think it's a shame because I think step functions are horrible. Also, on-premise functions as a service, I can't be on the public cloud. Why can't I have FAS? You kind of can, right? Open FAS would be the best one to look at. It's widely used. I know Alex very well, and he's been supporting the community, and lots of big commercial companies use OpenFast, and it's great. It works pretty well. If you've got a Kubernetes cluster on premise and you want some function stuff, it's probably what I'd look at today. Now, a lot of you may have said, well, what about Knative? Knative is a bunch of work that's coming right now. So Knative is basically Google saying, oh, people really don't want to work directly with Kubernetes. They want abstractions. Serverless is kind of where we want to move. And so basically Knative is them trying to create a new set of abstractions that are more developer friendly. The problem with this is twofold. Firstly, well, threefold really. Firstly, the gap between Google announcing something and it being production ready is actually often quite long. It took years for Kubernetes to get to where it is today. The second thing is the reason Kubernetes works so well and is so widely supported is because Google collaborated with a lot of people to make it work for what normal people do. When Kubernetes was first launched, it kind of worked how Google thought software development should work. And that doesn't actually match a lot of other people's ideas, a lot of other people's concepts. It was a classic example of groupthink. So a lot of people got together and sort of helped improve Kubernetes for the benefit of everybody. So it became very, very successful. With Knative, Google have decided not to develop it in the same way they have with, say, Kubernetes as part of the Cloud Native Computing Foundation. Instead, they said, no, we're going to spearhead all this development. And that makes me worried because they don't have a great track record of getting to production-ready software very quickly. And I worry without that community around it, it might take longer to get to a point of delivering anything other than what Google think you should do. The other one problem with this is it's built on top of a whole bunch of other layers. The early versions of Knative required that you had to use Istio, which is the service mesh stuff. You do need a service mesh underneath Knative, and the service mesh space is still also incredibly chaotic. So yeah, maybe in the future, but if you wanted functions as a service right now, I'd go OpenFast, not Knative. If you want to get started with serverless and start playing around, I think one of the nicest ways to avoid some of the horrific interfaces that the providers have given you around getting these functions working would be to start with the serverless framework. It works really nicely, it gives you a nice command line. It also works well in Teams. This is a good way of just hiding yourself from the horrendous kind of graphical interfaces around these things as well. Nice and simple, and works with different providers. This isn't the same thing as saying you could just take a function and transparently run it on any platform. It doesn't do that, but it at least gives you a uniform tool chain from which you can configure that kind of capability. For me, serverless is just about abstractions. And look, the history of computing is riddled with abstractions. Developers turn caffeine into abstractions. It's what we do, right? We create abstractions to make us more productive. And serverless is just the next generation of that. That's all it is. The problem at the moment is most of the quality service implementations are not available to you on-prem. And actually, if I look at what's been happening around, say, CNCF and that space, I don't see the gap being closed around databases as services or messaging products anytime soon. So functions as a service, sure, you might get good on-prem services, but the other stuff in that serverless space, Amazon S3 is amazing. There's nothing to even touch it running on-prem because it's not the kind of thing you can build on-prem easily. Because it's somewhere somebody's still got to write a 7 or an 8-figure check to NetApp for a big SAN somewhere, right? You can't do that on demand. So yes, you might get some of that serverless goodness on-prem, and some of those primitives and abstractions are going to be useful for helping drive that. but probably the best serverless stuff is still going to be available to you in the public cloud. It's all about finding the level of abstraction you're happiest with. If you realize you can give up on all of those, the greater control and low level access, you'll spend a lot less of your time worried about, plugging things in and wiring stuff up, which is fun, and spend a lot more time, just shipping software, which I think is all what we want to do. Independent deployability is all about enabling organizational autonomy. If I can do more stuff myself, I get more independence. And having somebody else do the work is fantastic. The secret to getting more things done is to avoid doing the things you don't have to. And again, serverless for me is just another example of getting somebody else to do the work. So in summary, think of serverless as more developer-friendly abstractions. Yes, there are servers there. You just don't have to worry about them. Functions can map very nice to microservice boundaries, but I wouldn't go as far as functions to state transitions. And just make sure you're careful about your data ownership boundaries. There's loads more information over at my website. I've got a lot of other talks that I've done. I think all the talks I've done over the last 12 years are available freely recorded online. I've got links to those on my website if you want to hear more about from my voice. I don't know why you'd want to, but there's information on my website. There's also information about my latest book and the work I'm doing on the second edition of Building Microservices. I'm in the process of working on that, and the second edition should be released in the middle of next year. If you go to my website, you can find links to how you can read the early version of that as well, as long as more information about the kind of work I do. That's me. I am done. But we've got lots and lots of time now for questions, and I'm hoping there's going to be loads of questions. So I'm going to stop screen sharing in case my email client pops up and you read my private correspondence with my wife or anything like that. And I think I'll hand it back to my lovely moderators.
Thank you very much, Sam. We'll give you a round of virtual applause because this is what we have for now. So I'm sure that our audience is more than excited about the content that we just had. And since they are so excited, I'm inviting them again to write all the questions that they have in the Q&A area, because now is the time to dedicate for this part. And I'm going to start with the first question. We have a question from Julian. Hello, Julian. He says that Kubernetes are okay. How about infrastructure as code?
So infrastructure as code is just defining my infrastructural setup, my desired state, how I automate that in code form. And it's a perfectly sensible concept. And there's nothing to say that it works very well with serverless. So I can use infrastructure as code to configure my Kubernetes cluster, to configure my virtual machine, or to configure how my service functions are set up and wired. So if you look at, I really like tools like Terraform, for example, which is sort of a cloud agnostic infrastructure as code open source tool. So another great product from HashiCorp. And you can use that to configure serverless offerings. You can also use it to configure Kubernetes. So if you've got a bit of a mix, you could use one tool chain for both. Another great tool in this space is Pulumi, which I really like. And I think for me, Pulumi is taking a lot of the core ideas of Terraform and again is making it even more developer accessible, which I think is a really, really cool thing. If you want to know more about infrastructure as code, my good friend Keith Morris has written a book called Infrastructure as Code. It's available from O'Reilly and it's excellent and you should read it. And he's also working on a second edition if it isn't out already. Oh, I think, Florian, you might be muted.
Thank you. You're right. Sorry for that. So let's go to the second question, because personally I know Julian. He's trying somehow to get some information about Terraform. Thank you, Julian, for the second question as well. What is your opinion on Terraform, given the fact that it supports also PaaS, FaaS via API, not talking about the infrastructure building features?
So I would use, so for me, Terraform is still not something I would expect a developer to create or write. They might make use of Terraform scripts, but it's not something for the average developer to work with. So I used to do lots of work with Puppet and Chef, but they weren't really, they kind of were more about managing your own infrastructure. They didn't really as quickly get their heads around the cloud. So when I'm working, if I'm automating cloud configuration, I'm absolutely just Terraform or Pulumi. Those are my two choices. I'd much rather use that for managing all my cloud resources in an automated, repeatable way than I would, something like CloudFormation, which is horrendous. There's a caveat around that, which is typically with things like Terraform, I'm only going to take that so far. So I would use Terraform potentially as a way to stand up and configure my Kubernetes cluster, for example, but I wouldn't use Terraform to define what pods I'm now launching, because that pushes you more into the developer world. So it's quite common that you'd use Terraform to say, here's my kube cluster and how here's it all configured. But when I'm actually deploying my applications, I might be using a different GitOps flow. This is more developer friendly. It's a great tool. I like it a lot. I would also, if you're interested, do take a look at Pulumi as well, which actually uses a lot of Terraform under the hood, but gives you a more code-friendly way of working. My friend Paul Stack, who worked a lot on Terraform for HashiCorp, is now involved with that project as well.
Thank you. I hope, Julian, you've got your answers and more than what you've expected. We are going further to Stefan, who is asking, can the future of serverless be considered functionless, abstracting even the function as a service? So
Stefan says, so even how the AWS gateway works. So I don't think you still have to have a unit of deployment. You still need to say, this is what I'm deploying. The function really is the box you're giving to AWS or Azure. I think the point you're making, Stefan, is wouldn't you like to abstract away the AWS API gateway? And oh yeah, because it's horrendous to work with. The thing is, conceptually, function as a service is really, really simple. Here is a function, run my function. The problem is both AWS and Azure, I don't really have much experience with the cloud functions on Google, require you to kind of get involved with all kinds of other moving parts on that platform. And so I have to configure the AWS gateway to call my function. So that's rubbish. So ideally, I'd be more abstracted from those things. There's a company, so I actually think that the concept of function as a service is brilliant and is the best developer-friendly abstraction we've had since Heroku. I think the current usability of those solutions from Azure and AWS are not where they could be, and I would hope they will improve. There are companies out there that are doing some really interesting things in this space that are giving us giving us a sign of what these things could look like. There was a company called Zeet, and they've just changed their name. I'm just Googling them because I can't remember what they're called now. So Zeet were doing some awesome stuff in terms of how to think about almost like what would a function as a service platform look like if we abstracted more details from you. So if you want to know more, they're now called Vercel. So VERCEL. As always, they're a niche player. They may well go out of business. They may well get swallowed. But I think it's showing what is possible. And again, I don't think some of these cloud vendors always get developer friendliness. I think Microsoft are more likely to nail this before Amazon does, unfortunately. I say that as someone I've been using AWS since 2008. I would like them to get it. I've had the rants with them. I've shouted at their people. They don't listen. I mean, why would they? They've got nearly $1 trillion company, and I'm me. But we can definitely do better. We can definitely do better.
Okay, I'm happy to announce you that we have, for the moment, like 23 questions. So we have a lot of questions.
Okay,
let's continue.
I'll try and go quicker.
Okay, great. Wouldn't be costly to have a whole microservices in a function? About also there are multiple questions here. What about the database when we are talking about microservices? Where should it be hosted, since a function should be stateless?
Yeah, the only time that running your whole microservice as a function is going to cost you more is if you have to allocate more memory to it, because you basically get charged a function. When you get charged for these things, you're charged based on how much memory you give the function and how long it runs for. Now, if running your whole microservice instance just to handle one aspect of the functionality means it runs with more memory because it's the full instance, or for a bit longer, that might cost you a bit more money. But I'd be amazed if it's a lot. So I don't really think it's a cost issue at all. I think the other question here is about the database. The microservices are stateless. The database runs on a different machine. You don't run the database in the function, it's elsewhere. So like every stateless service you probably built, you don't want the state in the running process. You stick it in a database. So that could be on AWS, that could be RDS, it could be a database you're running, DynamoDB, whatever else. It's somewhere else. It's not in the function. The function just talks to database and you put data in, pull data out, just as you would running a normal instance of a microservice.
Okay. The next question, well, it's more of a statement, so I'm guessing that it's more of a curiosity about your perspective on that. So with serverless functions, we can't recycle and reuse objects which are expensive to create. You can't implement object pooling.
Yeah, so I'll separate those out. I mean, object pooling is, so firstly, I'll answer the second question first. Object pooling is often required where you have a continual running process that's going to handle multiple requests. Your process is only ever going to handle one request. Therefore, a lot of requirements for things like object pooling just isn't needed. This would be the kind of thing that you might have to change when going from a normal invocation to another. There are other types of pooling that become more interesting. Things like database connection pooling kind of goes out the window, and that can cause some issues. I did a talk called Confusion in the Land of the Serverless, which explores this in more detail. There's links over my website. In terms of creating expensive objects that can't be reused, again, that's often an issue, is that you're constructing things up front with the idea that your process is going to run for a long period of time. And if certainly this is the case in the JVM or the CLR, that's kind of common. So yeah, you may need to do some optimizations around those processes. But again, it may well be worth it if you offload a whole lot of work. Oh, you're muted again.
Thanks.
Oh, well.
I don't know why. I really like to talk, probably, and somebody is muting me. Okay, the next question. I really like this question. When we architect a monolith, we tend to make use of CQRS, for instance, or onion architecture or hexagonal architecture and other things. If we write new microservices, do you think we should avoid adding the complexity and keep architecture per microservice simpler? If yes, in what ways we can achieve this?
Well, I think it's important that all these things you shared or talked about are patterns, right? And it is always a mistake to kind of create any piece of software by just throwing a bunch of patterns in. Patterns are a solution to a problem, and you may or may not have that problem, and that solution may or may not be worth it. And so for me, I'm always thinking, well, what are the things I do and don't need? CQRS is absolutely not something I would be doing as a general thing. CQRS adds significant complexity to systems. It can sometimes be warranted. And now I've definitely talked to teams where it was exactly the right solution for them. I have spoken to a lot more teams that have adopted CQRS as a default way of building software and have ended up causing themselves an unholy mess. The same is true for microservices. Microservices should absolutely not be your default choice. Your default choice, if you don't know anything else about your problem space, should be stick your code in one process, have it run on one machine, and maybe talk to a database. And then you go from there based on your needs. The patterns you bring in should be about solving problems you have. Microservices shouldn't be a default choice, certainly. If I'm going to build microservices, of those things you listed, the one thing I kind of always do is hexagonal architecture, which really, when you get down to it, is just information hiding. And that's about having stable boundaries and keeping my internal implementation separate from my external communication. Now, if I'm going to build a microservice, I'm always going to build it using that hexagonal style. Those other things like CQRS, it's extremely rare when I encounter a situation that really requires that pattern. My own personal experiences, of course.
Thank you. Noted. Let's see the next question. What would it be a feasible serverless function scenario using KEDA?
So KEDA is it's basically event-driven auto-scaling on Kubernetes. So the idea is it's like something happens and I spin up more instances based on that. Now, I think theoretically you can use Kida to sort of implement service type workflows, but my understanding is a lot of Kida is based just as much on scaling up based on other criteria. The kind of thing with Kida is you're still kind of working with pods, right? I'm spinning up a pod, so I've still got to create my pod in the first place. So when I spin up new instances, I'm launching something else. So I'm still working at the level of Kubernetes primitives. So sure, it could be a building block. It's the kind of thing I might consider using if I'm trying to create a function as a service like platform for internal use inside my organization, for example. But if I'm on the public cloud, I wouldn't bother with it. I just use serverless stuff. I might say actually some of my workflow really needs to run Kubernetes, and I'll use a managed Kubernetes platform like EKS. Absolutely. If I was then on Amazon or Azure, I wouldn't use Kida to then spin up functions when I could do that with Lambda or Cloud Functions. The only thing I'd say about that is when you start getting in, you can get in situations where cost effectiveness kicks in. Jan Say, who blogs at theburningmonk.com, has done some great analysis looking at the cost effectiveness of of sort of serverless function as a service workflows. And at a certain point, when your function's getting enough invocations, it can sometimes actually be more cost effective for you not to run them as, say, Lambda functions, but actually just to now go back to having, say, a running EC2 instance serving that load. So when you get into cost optimization things, that might push me back towards, if I've already got a Kubernetes cluster that's got spare capacity, maybe I'll do something there instead. But for me, that's an optimization issue rather than a default approach.
Thank you very much. The next question is from Gabriel. He's asking you, I was wondering, why don't you recommend the table storage from Microsoft Azure? It is because of limited scalability, or did you encounter other issues?
It's not hard to read between the lines and ask the right questions and get the impression that Microsoft doesn't really want you to use table storage and would rather you use other things in the same way that Amazon don't want you to use SimpleDB. And that's not to say they're necessarily bad. It's just that if you're starting today, there are probably better options for how you store your data. SimpleDB on AWS, for example, is where a lot of the ideas behind how Amazon built scalable systems were tried and tested. They learn how to do things differently afterwards. And so they don't say they're not supporting it. They absolutely are supporting it. You can still use it because they want to take your money. They're not stupid. This is something Azure and AWS are excellent at. They do not turn off products. And that makes you feel better. You're not always worried about being locked in. Google are terrible at this. They turn stuff off way too quickly. And that's why enterprise companies throw up their hands with them. So it's there. I'm sure it works based on its criteria. I would just say if you've got an honest conversation with someone from Microsoft, they'd probably tell you if you're starting from scratch, there are better options for you. No need for you to migrate off. If table storage is working really well for what you've built now, no reason to switch. But there may be better things for new systems you're looking to build.
Okay. Next, we have a question from Robert, more client-oriented. He's wondering if there is a service or a way to write serverless functions using TypeScript. Do we need to translate it to pure JavaScript and deploy?
Yep, not a problem at all. The AWS Lambda, when it launched in 2014, was for JavaScript runtime. So it supports a certain version of the Node runtime. So you can just package that up, do your transpiling, and you're away. So not an issue whatsoever. Because you don't really need a TypeScript runtime, you just need a kind of certain version of Node in the library. So you can, not a problem at all. And I'm pretty sure you could even do that on Google as well if you want to. So yeah, go at it. I'm a big fan of TypeScript. So I wish you good luck.
Thank you. I'm also a big fan of TypeScript. The next question is from Konstantin. Thank you, Konstantin, for this question. And it states that it is possible to run stateless Docker containers.
I mean, sort of. I mean, the way functions are stateless is that when a second invocation comes in, it's like we're hitting a new runtime. It's not actually what the function platforms do, though. Some function runtimes, like the JVM or the CLR, they take a while to spin up. They take a while to warm up. So when you invoke one of them, they like, so they don't want to just shut them down and restart them afresh. They actually keep them locked sitting around. And so when subsequent requests come in, They divert them to your function instances that are not being used right now. You're not getting charged until they're used. The way they make them stateless is basically what happens in terms of the SDKs and stuff, and the kind of how they package that up. So you could probably do something similar with the container workloads. But if you really want to make it stateless, probably the easiest way to do it is to code it to be stateless. And there's a lot of value in just coding to be stateless. You can't rely entirely on your deployment platform to keep something stateless unless you shut it down and fully restart it in between each invocation, which for something like Go or Node.js or Python or Ruby, so the interpreted languages, they spin up real fast. You could probably do that just by shutting it down and restarting it every single time. That's going to kill you on the JVM or the CLR because they're just going to take too long to warm up. So then just code for statelessness. And look, you shouldn't be doing shared mutable state inside a process, full stop. You shouldn't be doing session replication, right? Those things kill you. If you need to replicate between requests, stick them in local storage and cookies, stick stuff in databases, you will be happier. The world of building stateful, scalable software is a dark and murky place full of really interesting PhDs to be got. So by all means, avoid that world if you can.
Cool. Next question. I think this is some sort of question that we all have when something new arrives in the technology stack, and we are just wondering, is this for the future? And this is exactly the question for the next question is serverless the future? Are microservices here to stay?
Well, we'll separate those. Yeah, they're separate conversations, right, in a way. But I mean, obviously, as a person who makes a living partly writing books about microservices, I think you can tell that I'm definitely not biased when I say that microservices are obviously here to stay forever, and you should definitely hire me. No, I don't know about microservices. Serverless, yeah. I mean, serverless isn't, as I mentioned earlier, serverless isn't just the future, it's also the past. The very first things that AWS launched was serverless products. We just weren't ready for them, right? We weren't ready for that shift in mindset. It was only, when they built things that looked like old-fashioned infrastructure, we got, oh. I think serverless is absolutely the future of what most developers will be using to deploy and manage their code over time. It may not be the present for everybody, and as I mentioned, some of the existing implementations aren't fantastic, but it's definitely the future, I think, of where we're all going. Whether or not microservices are there to stay, I don't really know. It's hard for me to say. As our deployment abstractions shift and change and the nature of software changes, that's interesting for me. I think some of the concepts around microservices are here to stay. And I keep coming back to information hiding. 1971, David Parnas wrote a paper about information hiding that talks about how we define module boundaries. And it's still as true now as the day it was written. And it's a thing we keep losing sight of. A lot of people are using microservices just because they found they don't have the discipline to do information hiding inside a single process system. That, for me, I think is here to stay. I think what we are also seeing is shift in, you're seeing more language runtimes, realizing what Erlang can do. We may well start moving towards more language runtimes that allow for hot deployment on modules within a single process. Unikernels may well make a comeback. I don't think they've gone. So not sure about microservices, but serverless, absolutely here to stay. Microservices, not so sure. But please do buy my book. I've got a mortgage.
Perfect. Thank you very much. The next question is a very nice question, to be honest, due to the fact that when we are building software, we have to keep into account always the quality. So the question is the following: how do you test your services if they are implemented as serverless?
How do you test them?
Yep.
That's not really a problem in a way. Well, okay, I take it all back. Here's where things get interesting. And here's where I said, some of these platforms are better than others. Now, obviously one of the ways to test it is just to deploy it and run it. Now, if you've automated how you set up your cloud infrastructure and your cloud resources, spinning up dev and test environments should be a trivial affair. So if you've automated things by setting up, so I can set up a dev environment using a Terraform script that wires my things together, that actually can be quite straightforward, but does then sort of imply I'm actually running and developing in the cloud. And the problem is, you know, I lived in Australia for many years. I love it in Australia. My wife's Australian. The internet's not good. So when you're constantly pushing stuff to the cloud, especially if I was working with clients who are not in Australia, your workflows were just horrendous. It's like the internet in Australia seems like it's like the packets are being carried on the backs of small mice running along bits of wet string into. That's how it feels. So when you're developing the cloud, that can be quite bad. This is one area which is problematic for AWS. They don't really go out of their way to make local development easy. They don't really care about local development. They wish the local machine did not happen. They would rather you run in the cloud and give them money. If you look at the early stuff done around AWS functions, for example, they did nothing around local emulation. It was an open source project that someone created called SAM that actually allowed you to kind of emulate what running a Lambda function was like. And it is not a perfect emulation. So it wasn't even a first-class concern of AWS. Microsoft is head and shoulders above here. So they've got some amazing stuff. So I can run a function locally on my machine and have it triggered from the cloud. So I can have an API call made in Azure that actually calls a function on my local laptop. And I'm really running, I can sit there with a debugger, but have it triggering. So I can kind of have some stuff running locally and some stuff running remotely. I can also invert that. I can actually have my Lambda function, well, my cloud function running in Microsoft and attach a debugger remotely to it. I can't do that on AWS. So the dev and test cycles depend a little bit on how well that's supported by the underlying platform. Again, this is the issue, right? You're buying into somebody else's abstractions and the tooling they give you. Microsoft are definitely putting their best foot forward and trying to be developer friendly. No matter what else you might think about the quality of their services, that's definitely something they're doing actively. And so I do think some of that dev and test story is nicer around some of those Microsoft, the cloud functions than they are around other pieces. But some of the serverless stuff only exists, you know, in the cloud. And so some of that validation just means you have to run tests in the cloud. But then again, you know what? You get a dedicated account for your CI and your test instance. You just use your automation to build a copy, albeit a smaller copy, and run your tests there. And that's, you know, the easiest way to do it.
If the system is somehow constant in the term of nodes, same VMAs, is replacing Docker Swarm with Kubernetes worth?
I mean, yeah. I mean, look, look, Docker Swarm may have got to a place where it's not terrible now, but it's dead, right? I mean, it's the nicest possible way. So Docker dropped the ball on Swarm repeatedly. They had a thing called Docker Swarm that didn't work very well, had a lovely command line interface, but was overly simplistic and had all kinds of nasty failure modes. They then completely rebuilt Docker Swarm, but didn't deprecate the old tool. And their new tool that they released was called Docker Swarm Mode. So then you had Docker Swarm and Docker Swarm Mode that were completely different tools and products. And while they were messing about with all this, Kubernetes ate the world. If you want, as I say, if you want the best container orchestration platform in the world, it's Nomad from HashiCorp. If you want the best container orchestration ecosystem, it's Kubernetes. That's going to have the widest company support, commercial offerings, open source offerings. There's a good reason to switch from that point of view. That said, migrating may not be easy. So for you, it's more about, is Docker broken for you, right? Docker Swarm broken for you right now? But I would be getting off that burning ship. Okay, I might be unfair. Docker Swarm might not be actively a burning ship, but let's imagine it's a really hot day and the ship is made entirely out of very dry wood and someone spilled petrol all over it and someone's smoking a cigarette. So it's about to catch fire. So you might want to jump off now. I love a lot of the stuff that Docker did. The software, some of the software was absolutely fantastic. A lot of the people that worked there were great, you know, high quality people. The work that Docker captains do is amazing. It's just really unfortunate that they kind of missed the boat on the thing that could maybe have made them a big deal. And it's sort of, I reflect now and I sort of see Docker as being the son of, you know, of the last decade. Great technology, couldn't make a business model out of it. And that's a real shame because they've got some great stuff. But Docker Swarm, I would be looking for a migration path off it in short order.
Great, thank you very much. We still have like 6-7 questions. Can we take all of them?
Let's go.
Yeah?
Let's go.
Perfect. The next question is the following. How are you seeing using cloud providers but not stick with only one provider? This is the first part of the question. And is this a possibility? Another part of the question is to move between providers with no code change intervention.
Yeah, well, that last one isn't going to happen. I mean, maybe no code. Okay, so the idea that you can transparently move workloads from one cloud provider to another isn't true, doesn't exist. So you've got things which are theoretically portable, like Kubernetes. So I can run a Kubernetes cluster on Amazon, I can run a Kubernetes cluster on Azure. And I've got a Kubernetes workload, I should be able to take it from there and to drop it in there, right? But I've got to set up that Kubernetes workflow. So I've got all the identity and access management controls. They're all configured slightly differently. I've probably got all the supporting infrastructure I need and tools that I've got to put on top. You do not get transparent portability with no work being done. Work has to be done by somebody. So theoretically, yes, but in practice, no. Second thing, building one application that runs on two cloud vendors is problematic. Because it costs you time, it costs you money, because you'll get charged for data going out of your one cloud into the other and on the reverse. So it can be quite expensive, actually. And it also will kill you in terms of latency. So what I tend to say with organizations is, if you want to have your multiple clouds that you work with, that's absolutely fine. That can balance your risk. By all means, buy into Kubernetes as an abstraction that theoretically gives you portability across those platforms, but do not expect that portability to be quick and easy. It will take time. It's doable and better than not having a shared abstraction, but it will take time. And don't build high applications that run on both cloud platforms at once unless you've really thought it through. Situations where I have done this before is where I'm basically running localized versions of applications out of different cloud vendors, but running the same application live, we were trying to replicate state and things across those things gets really tricky. So I would advise against it. So multi-cloud as a company, sure. Multi-cloud for an application, probably not.
I just realized that we skipped a question, and seems like it was an important question because it was voted. So the question is, how can I convince the company to move to serverless? Can you tell us if you have any experience on this kind of migration?
Yes, I mean, I've had experience in convincing people a lot in general. So the thing is, don't make it a big deal. Firstly, you're already using serverless if you're on the public cloud. If you're using Amazon S3, you're using serverless. If you're using SQS, SNS, you're using serverless already. If you want to make use of function as a service, you don't make it a big, massive undertaking. You pick one small thing. You pick the least important part of your application. You pick the simplest thing you've got in your system. You pick an administration function that gets run once a month. You pick maybe a piece of code that you run as part of your CI/CD process and run that as a function. You might have a housekeeping job that needs to delete log files. Why not implement that as a cron job in Lambda? Pick something easy. Don't make it a big deal. You ask for a little bit of leeway to try one small experiment. You do the experiment, show it works, play it back and say, look, it worked really well. And then you get the confidence and trust to try something bigger. And that's all it's not rocket science. Don't make it a big deal, pick something small, get it done, then go with something bigger. Okay.
Okay, thank you. So I just want to be sure I understood your this part. You are trying to say that doing some sort of small proof of concept and doing this incrementally might be a good approach.
Yeah, although for me, I'm always wary about proof of concepts. I don't believe it till it's done. Like honestly saying real. So for me, I wouldn't pick a complicated proof of concept that may or may not relate to a real world activity. I'd actually want to use it in a real world activity. So for me, it would be more like an exemplar. We did this, it's running, it's being used, I can point you at it, you now can't deny that it works. So for me, I would want to actually have something really running. And again, it could be something you do as part of your test process or your dev process. You could create a stub service as a function for use in your dev processes. That's a great way to get confidence with how it works in a non-production setting.
Okay, great. Let's go to the next question. Is it legal to have the code data in a public cloud?
Depends who you got the data from. I mean, if it's somebody else's data, maybe you shouldn't have done that. A lot of this is going to depend on a number of factors. It's going to depend what your local legislation says regarding the nature of the data you're handling. Some countries, and obviously countries within the EU, have restrictions about where you're allowed to store your customers' data. For example, the EU just basically ruled that you can no longer store your customers' data safely in the US. Previously, that had been allowed. Now you're not allowed to. It's not public cloud or private cloud. It's about location. So these are all things that are changing constantly. So I can't answer that question without knowing more specifics about that. One of the big pushbacks against serverless and public cloud has often been, I want it I want it in my country. And this is an area where Microsoft especially have been quite aggressive in rolling out local data centers running Azure so that you can now run in country. AWS are absolutely doing the same, although aren't doing it as aggressively. They've been having more bigger data centers. So you honestly talk to your lawyer and just make sure it's your data in the first place, right? I don't want you downloading stuff from Pastebin and just sharing it publicly, right?
Makes totally sense. The legal part, it's
yeah,
the most or one of the most important. Yeah. Okay. How do you avoid function? Let's say they are implementing typical CRUD APIs from becoming dependent on the same shared code.
Yeah, this is why I kind of mentioned that I used to talk about like running the different transitions of an aggregate as separate functions, and I've gone back on that, and that's because of this issue, right? So if you think about CRUD, you know, creating something, updating it, deleting it, they're all like state transitions on a thing, an aggregate. But there's often going to be shared code amongst those options. And if they're all separate functions, how do I make sure that shared code is consistent? It's sort of for this reason that I've backed away from that. And I probably wouldn't run CRUD as separate functions. I'd run them as a single function. And then now I can share code and I don't worry about it. If I'm only doing it around one single aggregate, it's still a very small piece of code. I don't feel I need to go any finer grained than that. So I kind of avoid shared code by only having one thing, and therefore I'm only reusing code within that single function around that single entity. So that's how I handle it anyway. Oh, muted.
Yeah, thank you very much. It's the third time in a row.
It's okay.
Yeah. Okay, so the next question is, could you please recommend a distributed cache solution that will be used as an intermediate layer between the database and the several microservice instances? I'm talking about the same microservice which was scaled up.
Okay. It kind of depends on what you're trying to do. So for me, like, what is it you're trying to cache? Because I wouldn't necessarily always say that it's okay, because if I put a cache, which means I have to change my application code, that's always a bit fiddly. If I'm looking to cache reads, I wouldn't use a distributed cache layer. I would probably use something like read replicas off a normal database. So for me, I couldn't really answer that question unless I know what it is you're trying to cache and why. There are sort of distributed cache layers. You see things like Terracotta and stuff like that in the Java ecosystem and stuff like on Hazelcast and stuff. They're fine, but when you're trying to cache data operations, it really probably reads you're trying to cache, in which case read replicas get you an awful long way. And that way your application doesn't need to change much. It might just need to know I go there for writes and there for reads, and I accept my reads might be out of date, but guess what? If I was reading out of a distributed cache, they'd be out of date anyway. That's probably what I would do in the first instance, unless there was, and I've never actually had to do anything other than that in my own experiences anyway.
Cool. Do you have any opinion on using Azure Kubernetes services as running open function as a service, I guess, on it for this moment? Any pros and cons?
I mean, I would say the only reason to run OpenFaaS on top of AKS is if you think it's going to be more cost effective and or you want the additional control that you get from OpenFaaS. The reality is it's not, OpenFaaS is great, but it's not going to be anywhere near as nice to work with as Cloud Functions. So I'd say if you're already on Azure and you want to also run some functions, just run functions. Otherwise, you know, you might end up with sort of something that's not quite as good running next to a platform that is much better. So I would only consider it if I've got lots of idle capacity in my Kubernetes cluster, and I'm worried about costs. So I would be tempted to not bother unless I would actually start with Cloud Functions, and then if I start seeing cost reasons to shift, then maybe look at OpenFaaS afterwards. That would be my preferred approach.
Yeah.
Yeah.
Thank you. So 2 more questions.
Yep.
The first one. What are your thoughts about Google's solution to function as a service, Firebase functions, Firestore as a database?
Yeah, this is for me where the Google stuff gets really confusing, because the whole Firebase stuff doesn't really feel as integrated with the rest of Google as some other parts do, because I've got Google Cloud Functions and I've got Firebase, and then like it confuses me an awful lot. I haven't used them enough to know. Some of the stuff, their Firebase DB is pretty good, I think, as a simple serverless database, but I don't really have much experience with their functions. It's not, and you know, again, it's another part of the confusion I have around Google's cloud offerings in general. They just, it doesn't seem to kind of hang together sensibly, and this, it sort of sticks out. It's not clear to me from a vision type of view how it fits in with everything else they're doing. I mean, at least I know with AWS, they're just trying to do everything at once. There's about 15 different ways of solving every single problem, and they all cost you money. I get that with AWS, right? But like, yeah, I haven't used them enough in anger to know. But I said the database I've heard pretty good things about.
Okay, and the last question. So guys, this is your chance if there are any other questions. It's the last minute, so hurry up. What about tracing a full user flow if the application is made up of serverless functions collaborating within an event-driven architecture? How do we approach that?
Yep, this gets kind of interesting. So you've got kind of 2, well, firstly, correlation IDs. So when you're firing events, you know, in general, when you're tracing event-driven systems, correlation IDs are how you do this. So you basically, when you fire an event, you put an ID in it, which is going to correlate all the events. The thing that picks it up receives that event, it pulls out the correlation ID. When you log, you can now log with that same correlation ID. It's written out, there's loads of people that tell you how correlation IDs work. One of the sorts of challenges around tracing in a serverless stack is what you want tracing for. If you're looking for just simple cause and effects, you know, this did this, then this did that, you can actually do most of that yourself just with logging. If what you're looking for is sort of more accurate timing based stuff, because of the nature of causality and, you know, machines having different clocks, you end up actually having to rely a bit more on what the service platform itself gives you. So, you know, it's not, you can't easily use stuff like directly use some of the distributed tracing tools from those functions. It's unfortunate, actually. This is one area where I do think that the FaaS providers could do better. There's things like the Open Tracing API, which was developed as part of Zipkin and is used by Lightstep and Honeycomb and Datadog. It's a common kind of API for helping tracing in general for event-driven or request response-based systems. There's more new work being done in a new kind of open standard API called the Open Telemetry API. It would be really easy, to my mind, for either Microsoft or Azure or AWS to support those common standards, and they haven't, and that's a real shame. So you're kind of a little bit restricted based on what you get out of the platform itself. But logs will give you a long way, and certainly, you know, take a look at what you get from CloudTrail or App Insights on Azure. But you might have more limited options if you use these things on your own steam. But there's nothing to stop you doing correlation IDs and logging correlation IDs, and you should absolutely be doing that no matter what system you're building anyway.
So I guess we are at the closing moment of the event. Sam, thank you very much for accepting our invitation and being so open into answering the questions. And I'm sure that you brought a lot of valuable information for the Yash IT community. I'm thanking also in the name of Centric for everyone that joined this event, and also for being so active and curious with all these questions. I'm proud to be part of a community that is continuously trying to evolve and grow on their technical skills and improve their projects. Please don't forget about the feedback. Our colleague Bianca added a link for us in order to receive feedback and continue on doing events and growing and being more oriented on the needs that you have. Stay tuned on Centric social media pages, Facebook, Instagram, LinkedIn, in order to get more details, and also in order to find out more information about the video of the presentation that we will have it posted in the next period. Thank you very much again, and keep on growing and enjoy your evening. Bye-bye.
Bye-bye.